Hey, I hope you all had a great weekend. We're going to do section 3.1.5 tonight, all mixed up. So problem 363, the sum of two numbers is 9. What's the maximum product that will result from the first number and the square of the second number? So let's take it one sentence at a time. The sum of two numbers is 9. I'm going to let x be the first number and y be the second number, just so I can talk about them with variables. So this first sentence is an equation. It's the sum of the two numbers, so it's x plus y, and the verb is my equal, 9. And the second sentence is asking a question, and we're going to try to figure out what is the maximum product that will result, there's my verb, of the first number, which is x, and the square of the second number. So the product of the first number and the square of the second number. So I'm not totally going to do this algebraically. I'm going to think about the numbers that can sum to be 9. So if I use 1 and 8, and then I run them through this part of the problem, it would be 1 times 8 squared, 1 times 64. I could also sum 2 and 7 and get 9. That would be 2 times 7 squared. 2 times 49 is 98. 3 and 6 can give us a sum of 9. That's 2 times 6 squared. 2 times 36, 72. We could also have 4 plus 5 to get 9. So that's 4 times 5 squared. 4 times 25 is 100. 5 plus 4 is also 9. So 5 times 4 squared. 16 times 5 is 80. 6 times 3. 6 plus 3 is 9. So 6 times 3 squared. 54. 7 and 2. So 7 times 2 squared is 28. And 8 and 1. 8 times 1 squared is 8. So back to the question. What is the maximum product that will result from the first and the square of the second? The maximum product was 100. I worked this before I recorded it, and I didn't think 100 was right, so I paused it just to figure it out. And back here, and you may have caught this when I did it, that was supposed to be 3 times 6 squared, and 36 times 3 is 108. So the maximum is this 108. Alright, 3-64 is another sort of classic problem. Delbert wants to make 200 milliliters of a 5% alcohol solution by mixing a 3% alcohol solution with a 10% alcohol solution. What quantities of each of the two solutions does he need to use? So this is a mixture problem. Lots of different problems fall into this heading of a mixture problem. And I had a teacher a long time ago that sort of drew these jars. So she had this one thing plus this other thing, and she said we're going to add them together and get this third thing, this mixture. So if you set it up that way, it kind of helps to build the equations that you're going to get. Delbert wants to make 200 milliliters of this 5% solution by mixing a 3% solution and a 10% solution. What quantities of each of these does he need to use? How much of this one? And how much of this one? So X would be the number of milliliters of the 3%. Y would be the number of milliliters of the 10%. So when we are ready to write our equations, and you've written it down this way, this is one of them right here. So many milliliters of the 3% plus so many milliliters of the 10% is going to give us 200 milliliters of the 5%. So that's one of the equations. The next one, we get it by multiplying this together, multiplying this together, and multiplying this together. So it is 3%, so 0.03 times the x. Now we're dealing with the solutions. So we have 0.03 x plus 0.10 or 0.1 y equals 0.05 times 200. Which is 10. So these are our two equations. The reason you multiply this x times this 0.3, x is a number of milliliters. So we have so many milliliters of the 3% solution, which is multiplying. So the first thing I would do is probably multiply this equation here by 100 in order to clear the decimals. So we're going to get 3x plus 10y equals 1,000. Is that right? Yeah. And now you've got two equations and two unknowns. You might do substitution or you might do elimination. Here's one problem for you all to try. Try not to guess of what the combination of the two numbers would be. Try to work it out algebraically like I did with that first example. Okay, I'll see you guys Wednesday. Bye-bye.